cosmic giants call. In the dawn of creation, when the young sun burned hot and wild, four rocky worlds formed near its fire, while farther out, giants were born: Jupiter, Saturn, Uranus, Neptune, massive behemoths shaped by swirling gases and gravitational might. As Earth's curious children looked beyond the inner planets they had touched, Mercury, Venus, Mars, the distant gas giants pulled at their imagination. Reaching them, however, meant crossing a deadly debris field, the asteroid belt. In 1972, Pioneer 10 braved this unknown frontier, navigating a region more empty than feared, and triumphantly soared past Jupiter, using its immense gravity to exit the solar system entirely. It paved the way for a cosmic vision born at NASA's Jet Propulsion Lab, a once-in-2 centuries planetary alignment offering a slingshot path to every outer planet. Thus, Voyager 1 and Voyager 2 were launched in 1977, robotic pioneers with hearts of silicon and minds of wire. Equipped with old TV cameras and 8-track tapes, yet designed to endure the void, they carried with them not just science, but soul, a golden record, Earth's greeting to the galaxy. Led by Carl Sagan's vision, this message whispered greetings in 55 languages and offered images, sounds, and music to any who might listen across time and space. As Voyager approached Jupiter, the king of planets, a swirling titan twice as massive as all others combined, it revealed a world alive with color, storm, and moons in chaotic dance. The grand tour had begun, not just of the solar system, but of humanity's deepest hopes: to see, to learn, and to be remembered among the stars. Jupiter's Hidden Majesty. Beneath Jupiter's swirling clouds lies a world more dynamic than once imagined, a planet of storms, secrets, and staggering scale. When Voyager approached, it didn't just glimpse a gas giant. It unveiled a colossal weather system eerily akin to Earth, with shifting bands and the legendary Great Red Spot, a cyclone so massive it once spanned 3 Earths. Even today, its persistence defies full understanding. Yet Jupiter's wonders didn't end with ancient storms. Voyager revealed something no one expected: rings, faint, delicate, ghostly halos born from dust shed by Jupiter's moons, remnants orbiting their parent in silence. This discovery shattered the notion of Saturn's exclusivity and crowned Jupiter a member of the ringed elite. But perhaps even more extraordinary were the moons. Io, Jupiter's innermost Galilean satellite, seethed with volcanic fury, its molten heart stirred not by internal heat, but by Jupiter's unrelenting gravitational pull, stretching and squeezing it in a tidal embrace. Sulfur geysers spewed across a tortured landscape, making Io the most volcanically active body in the solar system. Then came Europa, small and glimmering, its cracked icy crust whispering of oceans below. Scientists believe those buried waters, stirred by internal heat and laced with organic molecules, may hold the ingredients for life. If true, Europa might not just be a moon, it might be a cradle. The story of Jupiter, told through Voyager's lens, is not just about size and storms, but about potential, about the thin line between silence and life. Galileo's fiery witness. Years into its voyage, Galileo became an unexpected eyewitness to a cosmic catastrophe. In 1994, the spacecraft observed as Comet Shoemaker, Levy 9 was violently ripped apart by Jupiter's immense gravity, an astronomical accident that turned into one of the most extraordinary events in solar system history. Scientists had expected Jupiter's clouds to simply absorb the shattered fragments, but instead, as each icy chunk slammed into the atmosphere, they exploded with a force greater than the combined power of Earth's entire nuclear arsenal. Galileo recorded the deep, dark impact scars, some thousands of kilometers wide, etched into Jupiter's swirling face. These collisions revealed more than spectacle. They confirmed Jupiter's protective role in the solar system. Its gravitational pull, while destructive to passing comets, may have shielded Earth from similar fates, possibly giving life a chance to flourish here. Under Galileo's mission, two explorers approached Jupiter, one a main orbiter, the other a small atmospheric probe. Both arrived in December 1995. While Galileo settled into orbit, the probe plunged beneath the planet's cloud tops, diving 180 kilometers into its depths. There, it confirmed the presence of water vapor, recorded temperatures, pressures, and even lightning, providing the first direct sampling of the planet's dynamic atmosphere. Eventually, the probe was lost, vaporized in the depths. Years later, as Galileo neared the end of its mission, it too was intentionally sent into Jupiter's atmosphere in 2003. This fiery farewell wasn't just symbolic, it was a safeguard, ensuring that no microbial stowaways could contaminate potentially habitable moons like Europa. For the next 13 years, Jupiter remained a distant mystery, until Juno. Launched aboard an Atlas V, the solar-powered spacecraft arrived in 2016, not to scan the clouds, but to peer beneath them. Juno's mission, to understand how gas giants form, evolve, and what secrets swirl in their cores. Its looping orbits brought it within just 8,000 kilometers of the planet, like circling a basketball 1 centimeter from the surface, but at speeds exceeding 200,000 kilometers per hour. To withstand Jupiter's blistering radiation, 20,000 times stronger than Earth's, Juno was equipped with heavy shielding. Inside Jupiter's depths, hydrogen compresses into a metallic form, fueling an enormous magnetic field and hiding a core that's more complex than ever imagined. Juno revealed this chaotic interior in stunning detail, transforming Jupiter from a swirling mystery into a planetary laboratory. And just as Juno's data poured in, humanity prepared to turn its gaze once more toward Saturn, the next jewel in our celestial crown. Saturn's Silent Symphony. Each Voyager spacecraft reached Saturn just months apart, but together they unveiled a majestic world unlike anything seen before. They discovered previously undetectable rings, vast in reach, stretching over 200,000 kilometers across, yet astonishingly thin, averaging just 10 meters in depth. With newfound clarity, the rings were resolved into countless fragments, icy grains, rocky debris, and mountain-sized boulders, all circling Saturn at a staggering 880,000 kilometers per hour. Within this chaos, Saturn's peculiar magnetic field worked mysteriously, suspending dust particles above and below the rings, creating a haunting three-dimensional ballet. Voyager 2's dramatic imagery deepened the mystery surrounding these rings. Were they born with Saturn, or did they form from the violent breakup of a wandering ice moon torn apart by the planet's gravity? The puzzle lingered. Titan, Saturn's largest moon, was first seen by Christian Huygens in 1655, followed by 4 more moons discovered by Giovanni Cassini. Centuries later, their namesakes would lend themselves to one of the most ambitious planetary missions ever conceived. In 1997, NASA, ESA, and the Italian Space Agency launched the Cassini-Huygens mission, an unprecedented international effort. The mission consisted of 2 spacecraft, NASA's Cassini orbiter and Europe's Huygens lander. Huygens in harmony, these transatlantic explorers delivered discoveries far beyond expectations. Over 13 breathtaking years, Cassini and Huygens unraveled the secrets of Saturn, not just in its clouds and rings, but in its rich tapestry of moons, worlds of ice, mystery, and potential. What they found was so unexpected, so profoundly beautiful, it redefined what we thought we knew about the outer solar system. The legacy of Voyager had sparked curiosity, but Cassini-Huygens turned that curiosity into understanding. Cassini's final embrace. The first mission to orbit Saturn, Cassini delivered a breathtaking view of the ringed giant, flying directly through its iconic rings, an act of orbital precision that demanded every ounce of engineering brilliance. Each pass was tense. Would the spacecraft survive the fine debris? Would the electronics withstand the onslaught? But as it danced through the icy rubble, Cassini captured something astonishing. Saturn's rings were raining. Roughly 40 tons of material per second were falling onto the planet below. This wasn't just spectacle, it was science rewriting textbooks. Cassini unveiled the Great White Spot, a planetary hurricane, and watched as Saturn's bizarre hexagonal storm at the North Pole morphed in hue from icy blue to molten gold. Spanning 50 times the size of Earth's own hurricanes, this towering tempest became proof of alien weather systems that mirrored Earth in unimaginable scale. Then, on July 19, 2013, Saturn eclipsed the Sun, allowing Cassini to take one of the most spectacular images in human history. From behind the planet, 650,000 kilometers of rings glowed in silhouette, and there, like a speck in the void, floated Earth, 1.4 billion kilometers away. On that day, NASA asked all of humanity to look skyward as their photons raced toward Cassini's lens. But the moons of Saturn held the deepest secrets. One in particular, Enceladus, captured Cassini's gaze. From its striped southern pole, geysers erupted, shooting material from a hidden ocean beneath its icy crust. The spacecraft didn't land. It flew through the plumes and tasted the spray, warm water, complex organics, and a hint of life-supporting chemistry. Could this be a second cradle of life? If hydrothermal vents exist at the ocean floor, just as on early Earth, Enceladus might be alive, but it wasn't alone in mystery. Titan, Saturn's largest moon, veiled in a thick orange haze of hydrocarbons, called for a deeper look. So in 2004, the Huygens lander detached from Cassini and plunged into Titan's atmosphere. After a 22-day descent, it softly landed on an alien shore, the first landing on an outer solar system world. For 72 minutes, it transmitted data, mountains of ice, rivers and lakes not of water, but of liquid methane and ethane, carving an ancient landscape eerily similar to Earth's own primordial past. If life could form on Earth under such conditions, might it also be forming, right now, on Titan? After 20 years, 294 orbits, and countless discoveries, Cassini faced its final chapter. With fuel waning, the mission took one last bold step, diving 22 times through the gap between Saturn's rings and its cloud tops. Scientists hoped to determine the age of the rings, and in 2019 they had their answer. Saturn's rings are young, between 10 and 100 million years old, mere infants beside the 4.5 billion-year-old planet they encircle. In its final act, Cassini plunged into Saturn itself, transmitting precious data until its last breath, ensuring no contamination would reach Saturn's moons. Signal from the spacecraft has gone, the team declared, and so ended a mission born of curiosity, driven by wonder and sealed by fire. Cassini, the silent guardian of Saturn, was no more. Uranus, tilted enigma. Just over 2 centuries after its discovery, Voyager 2 soared within 82,000 kilometers of Uranus's cloud tops, becoming the first and only spacecraft to ever visit the tilted world. Uranus is an oddity in every sense. Through Voyager's eyes, we saw more than a pale blue dot. We witnessed high-speed jet streams sweeping across its poles and equator, painting a picture of dynamic, alien weather. But its strangeness runs deeper. Unlike any other planet, Uranus lies on its side, tilted at nearly 98 degrees. Scientists believe a massive Earth-sized object struck Uranus long ago, knocking it sideways and changing its destiny forever. Its atmosphere, chilling to an astonishing minus 224 degrees Celsius, holds the record for the coldest in our solar system, an icy shell in a region of space that receives less than 1,000th of the sun's light. The planet's pale cyan hue comes from the methane in its upper atmosphere, more concentrated than in Jupiter or Saturn. But like its giant siblings, Uranus wears a crown of rings. First discovered a decade earlier by the Kuiper Airborne Observatory, Voyager 2 added to the count, bringing the total to 11. Then came Miranda, As Voyager's images of Uranus's moon arrived, scientists were stunned. Miranda looked as if it had been torn apart, violently shattered, and then messily stitched back together. One half was a maze of furrows and fractures, the other a typical cratered moon, but somehow both lived within the same tiny world. Its cliffs, some over 20 kilometers tall, rise into the sky like frozen waves. On Miranda, with its feeble gravity, a jump off such a cliff would send you floating downward for 20 minutes, plenty of time to consider your landing. Uranus, distant and dim, once thought to be a quiet gas giant, was suddenly exposed as a tilted mystery, one of the strangest and most overlooked wonders of our solar system. Neptune's hidden fury. Not with a telescope, but with mathematics, Neptune was found. Long before it was seen by eye, its presence was inferred by the way its gravity tugged at Uranus, pulling it slightly out of line. A world discovered not through light, but through logic. When Voyager 2 set course for Neptune, the challenge was immense. At such great distances, the spacecraft's faint whispers required a monumental technical leap. Voyager probes are astonishingly quiet, and the farther they travel, the more powerful our ears must become. In 1986, NASA created the Deep Space Network. 3 communication hubs spread across the globe, each with a 120-degree field of view, one in California's Mojave Desert, another in Madrid, and a third near Canberra, Australia. These stations gave Earth constant contact with the distant probe, guiding its trajectory, commanding its instruments, and collecting the faint data signals it sent home. By 1987, the massive dishes were upgraded in preparation for Neptune's flyby. When Voyager arrived 2 years later, it revealed a haunting world cloaked in mystery. At least 4 rings of ice and rock encircled the planet. In the southern hemisphere, Voyager spotted the Great Dark Spot, a giant vanishing storm the size of Earth, a transitory hurricane with wind speeds reaching over 2,000 kilometers per hour, the fastest in the solar system. To maximize the science, engineers adjusted Voyager 2's flight path to intercept Neptune's largest moon, Triton. Unlike any moon we'd seen, Triton had a fragile atmosphere and bizarre geysers ejecting dark, sooty material. Not the water ice seen on other moons, but something stranger. These plumes scattered across the surface, streaked by winds that painted the moon in long, dark lines. A few days later, Voyager snapped its final photo. Neither Uranus nor Neptune has been visited since. Once just dots of light in our telescopes, the ice giants were revealed to be utterly different from Jupiter and Saturn, worlds colder, wilder, more extreme than ever imagined. With only one fleeting encounter, we are left with more questions than answers. After all these decades, the urge to return grows stronger, and beyond Neptune lies yet another mystery, the Kuiper Belt, a frozen realm of ancient rocks and icy bodies, remnants of the early solar system. Not discovered until 1992, this region holds secrets untold. At its heart, Pluto. Spotted in 1930 by 24-year-old Clyde Tombaugh, Pluto once held planetary status until its reclassification in 2006 as a dwarf planet. Still, it was never forgotten. The New Horizons mission was built to go where the Voyagers couldn't, toward that final, distant world. Launched from Cape Canaveral in 2006, it promised to answer the lingering question, what lies at the frozen edge of the solar system? Pluto's distant secrets. At nearly 5 billion kilometers from Earth, Pluto stands as one of the most remote outposts ever explored by humanity. Communicating with the New Horizons probe required patience, over 4 hours for a single round-trip signal, and data trickled back at just 1 kilobit per second, 50 times slower than 1990s dial-up internet. It took 15 months for all the information to arrive, yet each morning, teams around the world awoke eagerly to sift through every new image. Raw data transformed into wonder. Until New Horizons, Pluto's true size remained unknown. The mission revealed it to be 2,376 kilometers in diameter, the largest of the known dwarf planets. But it was the surface that stunned scientists. Vast nitrogen ice glaciers carved into valleys, towering 3-kilometer-high water ice mountains, blanketed in nitrogen snow, and complex patterns resembling works of art. Among these features lay a smooth, heart-shaped region, suggesting a young, dynamic surface only 1 million years old, not the ancient, cratered landscape many had expected. As New Horizons departed, it captured an ethereal image, Pluto's atmosphere glowing blue, sunlight illuminating nitrogen haze in a sky that mirrored our own. It was a final glimpse before heading into the interstellar void, yet Pluto was not the end. The data raised more questions, hinting at another massive presence tugging at distant objects, Planet 9. These distant bodies move in oddly aligned orbits, unlikely to happen by chance. Mathematical models suggest a super-Earth-sized world, possibly 20 times farther than Neptune. But if it's there, it hides in the densest part of the Milky Way, indistinguishable from the stellar crowd, a needle in a haystack, except the needle looks like hay. Meanwhile, the Voyager probes, our oldest spacefarers, continue their silent journey. In 1990, Voyager 1 looked back to capture a family portrait of the solar system. In one beam of sunlight, a pale blue dot, Earth. That image reminded us of our fragile place in a vast cosmos. Both Voyagers have crossed the heliopause, the boundary where the sun's influence ends, venturing into true interstellar space. They may whisper back to Earth until the 2030s, each signal a relic from the 1970s still echoing forward. They carry golden records, etched with humanity's voice and music, drifting endlessly into the galaxy. These missions weren't just explorations, they reshaped our cosmic perspective. Every encounter brought awe, every discovery rewrote the unknown. The depths of space called, and humanity answered. Rocketing cold ambitions. Gone was the world of alliances, as the Second World War gave way to a bitter new rivalry. In the ashes of conflict, the United States and the Soviet Union scrambled to seize the intellectual spoils, Germany's brilliant scientists and their terrifying innovations. From this scramble, the space race was born, its roots buried deep in war and weaponry. At its heart was the V-2 rocket, the world's first long-range guided ballistic missile, brainchild of German engineering, and the first human-made object to breach the edge of space. The Allies knew the V-2 had devastated Europe and Britain. They also knew the minds behind it could redefine the future. In secret, the US launched Operation Paperclip, spiriting away thousands of German scientists, engineers, and their families before their Soviet allies could do the same. Among them was Wernher von Braun, who would become a key architect of NASA's Apollo program. Meanwhile, tensions escalated. Ideology turned allies into adversaries. The Cold War set in, each side amassing nuclear weapons and seeking the ultimate delivery system, intercontinental ballistic missiles. American leaders assumed the Soviet Union lacked the capacity to challenge them in this arena. But in 1957, that illusion shattered. The Soviet Union launched Sputnik, the first artificial satellite to orbit Earth. It was a moment that stunned the world and ignited a new chapter in history. The battle for supremacy beyond Earth had begun. Sputnik's spark shock, announced to the world as the first intercontinental ballistic missile, the Soviet Union's R-7 could carry a nuclear payload across 8,000 kilometers, but its sheer bulk made it impractical for actual warfare. Soviet leadership, however, saw another use. Within weeks of the R-7's first successful flight, they authorized their scientists to adapt it, not for war, but for wonder. On October 4, 1957, the space age officially began. The Soviets launched Sputnik, named after the Russian word for traveler, into Earth's orbit. Rising over 900 kilometers above the surface, this polished aluminum sphere just 58 centimeters wide, didn't carry weapons or cameras. It carried a beeping radio transmitter, and with every pulse, it stunned the world. People everywhere turned their radios to catch the rhythmic beep, 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 a simple signal that declared a complex truth. Humanity had placed an artificial satellite in orbit. For some, it was awe-inspiring. For others, deeply unsettling. The US in particular was rattled. The idea that the Soviet Union had reached space first triggered panic and fascination alike. Thousands gathered at night to spot the speck of light soaring overhead, proof of a new era. The space race was no longer theoretical. It was real, and America had already fallen behind. Scientists turned to old ideas with new urgency. Isaac Newton's centuries-old thought experiment of throwing a stone fast enough to orbit the Earth was suddenly no longer hypothetical. Gravity wasn't just a force. It was now the frontier, and orbit had become the prize. First steps. Skyward. In a desperate push to match the Soviets' lead, the US Navy attempted to launch its own satellite just months after Sputnik, only to see disaster unfold as Vanguard exploded on the launch pad. With the nation's pride bruised and momentum slipping, the Army stepped in. Werner von Braun, former V-2 rocket engineer, brought over an Operation Paperclip, refined his Jupiter C rocket in record time. In just 84 days, he was ready. Collaborating with William Pickering and James Van Allen, Explorer 1 launched into orbit, not as a weapon, but as a scientific scout. It carried a Geiger counter that confirmed the existence of intense radiation belts surrounding Earth, later named the Van Allen belts, natural shields that would forever shape the future of manned space travel. As America regained confidence, the next frontier loomed, placing a human into space. But would a person survive in the vacuum? Could they breathe, think, return alive? The stakes were astronomical. In 1958, NASA formed Project Mercury and began searching for the right stuff, selecting 7 elite military test pilots from hundreds of candidates. Meanwhile, the Soviet Union trained its own cosmonauts. From that group emerged a 27-year-old Air Force pilot with a winning smile and unwavering poise, Yuri Gagarin. On April 12, 1961, from the same Kazakh launch site as Sputnik, he ascended aboard Vostok 1. In just 10 minutes, he passed the Kármán line, becoming the first human in space. Gagarin orbited Earth in just 108 minutes, saw its curvature, its fragile blue hue, and radioed back the immortal words, "I see Earth. It is so beautiful." But his mission wasn't finished. Re-entry was perilous. The spacecraft's modules failed to separate, spinning violently until friction burned through the tangled connections. With only seconds to spare, Gagarin ejected 2.5 kilometers above the ground and parachuted safely to Earth. His successful return marked a triumph not just for the USSR, but for all of humanity. We now knew a person could survive the void, return through fire, and live to tell the tale. The space age had truly begun. Triumph through tension. A month after Gagarin's historic orbit, America took its first human leap into space with Alan Shepard aboard Freedom 7. Though the mission lasted only 15 minutes and didn't complete a full orbit, Shepard's suborbital flight marked the U.S. entry into the space race. Just a year later, John Glenn would carry the American flag around Earth, circling it 3 times aboard Friendship 7. His every word and image broadcast live, a stark contrast to the secrecy surrounding the Gagarin. While both nations continued solo missions, the Soviets advanced once again by sending the first woman, Valentina Tereshkova, into orbit aboard Vostok 6. Her 3-day journey was both groundbreaking and grueling, plagued by space sickness and lack of empathy from ground control. Nevertheless, it carved a critical path for women in space exploration. As missions evolved, so did ambition. The Soviets retrofitted their Vostok into the 2-seat Voskhod, a cramped craft that sacrificed safety for speed in the space race. even removing ejection seats and pressure suits. Still, Voskhod 1 set a record altitude and successfully returned its crew. Then came Voskhod 2, and with it, Alexei Leonov, the first human to walk in space. Tethered only by a 5-meter lifeline, Leonov floated above Earth, marveling at the planet's fragile beauty. But his triumph nearly turned fatal when his suit ballooned in the vacuum of space. Unable to re-enter the airlock, he vented oxygen in a desperate bid to compress his suit, surviving by minutes. After an emergency landing deep in the Siberian wilderness, Leonov and his crewmate waited days for rescue. The risk-heavy Soviet program pressed on until tragedy struck in 1967 when Vladimir Komarov's Soyuz 1 parachutes failed, making him the first human to die in spaceflight. Just months earlier, America suffered its own heartbreak. 3 astronauts lost in the Apollo 1 capsule fire. Yet through loss, both nations forged forward. While the US claimed the moon, the USSR pursued orbit with the Salyut space stations, pioneering long-duration missions and the science of living in microgravity. In 1973, the US launched its own orbital outpost, Skylab, assembled from Saturn V parts left over from lunar missions. Damaged upon launch, Skylab was saved by its first crew's daring spacewalk repairs, proving once again that triumph in space has always walked hand in hand with tension, risk, and the relentless spirit to survive beyond Earth. Boundless human resolve. By the legs, while one astronaut anchored the other, a long pole with scissors at the tip was rotated clockwise to cut the tangled cable, a silent ballet of precision and microgravity. Through sheer ingenuity and relentless effort, the crew managed to restore power and bring the Skylab space station to life. Its core was a converted Saturn rocket, transformed into a functioning habitat with a galley, a zero-gravity shower, and modest sleeping quarters with beds fixed to the walls. Living in space, however, demanded a constant battle against microgravity's toll. Fluids pooled in faces and limbs, hearts shrank without resistance, bones lost density, and eyes distorted shape. To counteract these effects, astronauts exercised rigorously, preserving muscle and mind. Skylab orbited Earth for less than a year, during which 3 rotating crews conducted 270 experiments. But it was the astronauts themselves who became the most vital study, testing whether humans could stay healthy, stable, and sane in space. The final crew, worn out from intense schedules, shut off communications for a full orbit, forcing NASA to rethink expectations. A renegotiated pace followed, and the mission's objectives were still achieved, teaching NASA a crucial lesson. Even the toughest explorers need rest. Meanwhile, political tensions on Earth saw a brief thaw as the US, USSR, and UK signed the Outer Space Treaty in 1967, forbidding the militarization and sovereign claims of celestial bodies, an effort to keep space a realm for peace and exploration. This spirit culminated in the Apollo-Soyuz test project, where spacecraft from both rival nations were launched just hours apart, modified to dock using the newly invented androgynous peripheral attach system. As the modules linked in orbit, American Commander Thomas Stafford and Soviet cosmonaut Alexei Leonov exchanged the first handshake in space. Their symbolic gesture, watched worldwide, marked not only the end of a fierce space race, but the dawn of collaboration beyond borders. Over 44 hours, the crews shared meals, conducted experiments, and even observed the sun's corona during an eclipse. 2 former enemies united in the pursuit of knowledge. This unlikely alliance reminded humanity that space exploration, born of rivalry, could mature into partnership, a shared odyssey beyond Earth, shaped by curiosity, respect, and the boundless resolve to reach farther together. Orbiting human dreams. As human ambition reached farther, it became clear no rocket could single-handedly hoist an entire space station into orbit. So bit by bit, humanity assembled its home in the stars. In 1986, the Soviets launched the Mir space station, Mir meaning peace, and over the next decade added 6 pressurized modules. Mir became more than hardware in orbit. It became a symbol of a world in transition. Cosmonaut Sergei Krikalev, aboard Mir during the collapse of the Soviet Union, left Earth a Soviet citizen and returned a Russian, stateless in space yet serving a greater cause. Mir welcomed astronauts from North America, Europe, the Middle East, and even a Japanese TV journalist. It was a true beacon of international cooperation, but as the station aged, hygiene and hazard crept in: mold, computer failures, even fire. Frozen yellow urine droplets orbited the station like a grim halo, damaging solar panels. Still, despite being abandoned in 2001, Mir was a scientific and symbolic success. Meanwhile, back on Earth, NASA was dreaming bigger: a reusable spaceship. The space shuttle was a leap from science fiction into reality, a winged spacecraft that could launch like a rocket and land like a plane. On its 1981 maiden flight, Columbia soared, flanked by solid rocket boosters and powered by a massive external fuel tank. Its aluminum frame was shielded by 24,000 heat-resistant silica tiles, designed to endure 1,260 degrees Celsius on re-entry. Over 30 years, 5 shuttles flew 135 missions, deploying satellites, building space stations, and even enabling untethered spacewalks, like Bruce McCandless's historic solo float in 1984. But triumph was shadowed by tragedy. In 1986, Challenger disintegrated 73 seconds after launch due to a faulty O-ring. In 2003, Columbia was destroyed during re-entry after foam debris fatally compromised its wing. 7 lives lost in each disaster, reminding the world space is hard, yet through grief came resolve. The shuttle program pressed on, shaping generations, though never quite meeting its budget goals. Atlantis' 2011 final flight marked its end as NASA shifted gears to international cooperation. In 1998, the U.S. module Unity joined the Russian Zarya, and the International Space Station, ISS, was born. Over the next decade, nations contributed labs, solar arrays, and habitats, turning the ISS into a permanent microgravity laboratory and symbol of unity. Since 2000, humans have continuously lived in orbit, and after the shuttle's retirement, Russian Soyuz spacecraft became the space taxi for astronauts, a powerful irony for a Cold War-born program. Then in 2020, history turned again as SpaceX launched astronauts from U.S. soil, ushering in an era of commercial spaceflight. The ISS became a springboard for science, diplomacy, and the democratization of space, teaching us how to live in orbit, grow food, manage radiation, and prepare for deeper journeys. Its legacy is not just what it achieved, but what it made possible. Soon, the ISS will retire, but its spirit will echo across the cosmos, proof that humanity, when united, can touch the stars. Moonwalker's final descent. Once in lunar orbit, the Apollo crews faced their final and most perilous task: reaching the moon's surface. While Michael Collins remained aboard Columbia, orbiting in isolation, Armstrong and Aldrin began their descent aboard Eagle. Trust was placed in an automated guidance system, but as the lunar surface neared, a barrage of computer alarms threatened the mission. The onboard radar was mistakenly guiding them into a deadly field of boulders. Armstrong took manual control, skillfully steering the Eagle while fuel rapidly depleted. 60 seconds, then 30, and finally down to 16 seconds before touchdown. Tranquility Base here, the Eagle has landed. Relief swept through mission control as a billion hearts around the globe exhaled together. Though scheduled to rest, the astronauts defied instructions. They needed to explore. In just 12 years, humanity had journeyed from Earth's edge to another world. A small step, televised live by a camera that now stands among the most culturally significant artifacts in human history. As Armstrong and Aldrin explored, deploying seismic sensors and collecting moon rocks, Collins orbited alone, disconnected from every living soul for 47 minutes each pass, yet tethered by responsibility. Back on the surface, time ran short. Told they lacked sufficient rock samples, Armstrong scrambled, declaring the gathered specimens might not be perfect, but they had them. Even today, those rocks continued to unlock secrets. Meanwhile, in orbit, the Soviet probe Luna 15 attempted a rival landing but failed, crashing just hours before the Eagle's departure. The race was won. With their duty fulfilled, the Apollo 11 crew launched from the moon, reunited in orbit, and safely splashed down in Earth's Pacific waters. Kennedy's dream fulfilled. Humanity, once bound to a single world, now had proof that it could leave and return. And with that, the age of true exploration had just begun. Lunar future ignites. The moon is no longer just a distant dream. It's becoming a destination, a base, and a bridge to new worlds. No longer a mere stepping stone, the moon is now seen as a vital resupply and refueling station, drawing the eyes of both nations and private pioneers. Government agencies and commercial companies are forging powerful partnerships, building landers and rockets with shared ambition. Heavy launch vehicles are no longer disposable relics. Thanks to visionaries like SpaceX, they return home, reusable and revolutionary. SpaceX, once a supplier for the ISS, now stands at the forefront of human return to the moon, promising new footprints within the decade. NASA's Artemis program, named for Apollo's twin sister, carries humanity's renewed hopes. Atop the mighty Space Launch System, the Orion capsule leads the charge in a carefully staged mission, first to orbit, then the moon, and finally, Mars. Its test flights soared to nearly 6,000 kilometers above Earth, laying the foundation for lunar settlement. These future lunar bases will serve as scientific outposts and launch pads for deeper journeys. But life on the moon won't be easy. No air, no magnetic field, and relentless radiation pose a massive challenge. Yet the moon also unites us. Like the ISS, it fosters global cooperation. It offers not only science and inspiration, but also resources, especially water ice at the poles, which can be transformed into fuel and sustenance. The dream persists because it's deeply human. Curiosity compels us to explore. From lunar dust to distant stars, each step out there is a step inward, toward understanding ourselves. The moon calls not just explorers, but the future of our species. The journey to become multiplanetary begins here. Venus reveals secrets, intact and defiant. Venera 7 made history, transmitting humanity's very first message from the surface of another planet. For 23 scorching minutes, the Soviet probe withstood Venus's hostile wrath before surrendering to heat and pressure. It marked the beginning of the USSR's remarkable Venera program, which uncovered a planet veiled in mystery and brutality. With surface temperatures soaring to 475 degrees Celsius and atmospheric pressure 91 times that of Earth, Venus was revealed as a suffocating volcanic inferno. In 1975, Venera 9 sent back the first haunting image, a black and white glimpse of its rocky terrain. Though it looked unremarkable, it was groundbreaking. These missions laid the foundation for future probes, each more advanced and resilient, pushing deeper into the planet's secrets. By the 1980s, the Soviets were systematically decoding Venus, while NASA prepared a broader strike, Magellan. Launched from the shuttle Atlantis in 1989, Magellan used radar to see through the planet's thick clouds, mapping 98% of the surface and revealing a dynamic world of volcanoes, lava plains, and seismic activity. Despite its restlessness, Venus's crust is ancient, unable to recycle like Earth's due to a lack of tectonic plates. Yet in its early life, Venus might have been Earth's twin, wet, temperate, and potentially habitable. But over time, its proximity to the sun, and a runaway greenhouse effect erased any trace of water. Today, it's an ominous warning. Could Earth meet the same fate? That mystery is why we study Venus, not only to understand her, but perhaps to save ourselves. Later, ESA's Venus Express unveiled strange, freezing high-altitude clouds where carbon dioxide could snow, suggesting life might cling to the planet's skies in forms unlike anything we know. The enigma of Venus remains, forever shrouded in cloud, yet slowly yielding her truths to the robotic emissaries we send.